and strategies for leading railway experts and policymakers. We are pleased to introduce 3 landmark publications by ADVI that provide critical policy insights on high-speed rail and urban transport development in Asia. The first book, Frontiers in High-Speed Rail Development, highlights how HSR serves as a powerful engine for regional development while addressing complex implementation challenges. The second book, Policy Messages for Planning and Implementing High-Speed Rail in Asia, underscores that HSR's transformative impact is driven by nonlinear, dynamic interactions between technical and social systems. The third book, Urban Transport Transitions in Developing Asia, From Challenges to Change, shifts focus to urban mobility, policy transitions, and sustainable transport solutions. To further disseminate these policy insights, ADVI launched this global webinar series. The inaugural session in May 2024 examined Italy's HSR experience, focusing on open access competition, private financing, and ESG bonds. In December 2024, our second session highlighted the People's Republic of China, emphasizing spatial planning alignment and the strategic shift from demand-driven to supply-driven infrastructure growth. Our third session in October 2025 explored Spain's HSR model, underscoring the critical necessity of demand-based planning for long-term fiscal sustainability. In April 2026, the series covered Uzbekistan's experience, tracing its trajectory from Soviet-era broad-gauge heritage to modern HSR operations supported by Korean technology transfer. In July 2026, Part 1 of the Republic of Korea series explored how South Korea adapted foreign technology to build sovereign capability and operate a nationwide high-speed rail network. Today's webinar, its succeeding Part 2, continues this conversation, focusing on national policy considerations, long-term financing, governance, and smart operations. Building on the foundation laid in Part 1, where we examined Korea's early technology adaptation, localization, and domestic capability building, today's Part 2 session pivots toward translating those technical capabilities into a comprehensive policy framework for nationwide high-speed rail deployment. In this session, our discussions will center around 3 core focus areas. First, system expansion and governance, where we'll look at expanding high-speed rail networks through both regional and global lenses. Second, financial sustainability, focusing on long-term funding strategies, earmarked accounts, and vertical separation frameworks. Finally, third, digitalization and smart O&M, to explore how cutting-edge tools like AI, digital twins, and predictive maintenance can streamline long-term operations. In all, our overarching objective today is to extract actionable policy insights and strategic takeaways that developing Asian nations can adapt when planning, financing, and operating their national HSR networks. Agenda Overview. The webinar will begin with opening remarks, followed by 4 keynote presentations covering Korea's HSR evolution from regional and global perspectives, financing structures, and institutional O&M models. Then, our session continues with a concluding session, a panel discussion, and concludes with a feedback survey and closing remarks. Disclaimer. This event may be photographed, recorded, or live streamed. By participating, attendees consent to the use of their image and comments in ADVI media publications and external communications. House rules. Please ensure punctual attendance and remain in the session until the end. Use the Q&A box for questions and the chat box for sharing thoughts. Please rename your Zoom name to include your name, affiliation, and country. These guidelines ensure a smooth and engaging webinar experience. Opening remarks. Professor Bambang Brojonegoro, Dean and CEO of Asian Development Bank Institute, will deliver the opening remarks. With extensive experience in government and academia, Professor Brojonegoro brings valuable insights into economic affairs and national development strategies. Keynote Speech 1. History of High-Speed Rail Technology Development in the Republic of Korea from Regional Perspective. This session traces government-led R&D across rolling stock, track engineering, and signaling, as well as the regulatory frameworks enabling national safety control. Keynote Speech 1 Moderator, Dr. Minjong Kim, Senior Researcher at the Korea Railroad Research Institute, KRRI, specializing in railway environmental performance, indoor air quality, and AI applications. Keynote Speech 1 Speaker, Dr. Myung Sagong, President of KRRI. With decades of research leadership in civil engineering and national railway technology strategy, Dr. Sagong will outline Korea's journey towards self-reliant rail capability. Keynote Speech 2, History of High-Speed Rail Development in the Republic of Korea from Global Perspective. This presentation examines Korea's transformation from a technology importer into a global railway partner through a structured four-stage evolutionary model. Keynote Speech 2 Moderator, Dr. Myung Sagong, President of KRRI. Keynote Speech 2 Speaker, Professor Yang Sang Lee from Shimonoseki City University. Former Vice President of Wusong University and Editor-in-Chief of the 20-year history of KTX, Professor Lee will share actionable frameworks for international railway cooperation. Session 3. Challenges and Issues in Financing HSR in Republic of Korea. This session analyzes the fiscal instruments used to finance Korea's infrastructure, from government bonds to modern integrated PPP concession packages for export. Keynote Speech 3 Moderator, Professor Yang Sang Lee at Shimonoseki City University. Keynote Speech 3 Speaker, Dr. Jin Young Park, Adjunct Professor at Korea University and ADB Consultant. Drawing on 25 years of transport policy and infrastructure finance experience across Asia, Africa, and the Middle East, Dr. Park will detail the financial mechanics behind capital-intensive rail networks. Session 4. Institutional Arrangements for Operation and Maintenance of High-Speed Rail in the Republic of Korea. This session explores Korea's tripartite governance model, KRNA, Korail, SR, Hyundai Rotem, and digital maintenance innovations. Session 4 Moderator, Dr. Jin Young Park at Korea University. Keynote Speech 4 Speaker, Professor Woo-Soo Yo, Head of Civil and Environmental Engineering at KAIST. An expert in smart mobility and AI-driven transport, Professor Yo will explain how condition-based predictive maintenance reduces HSR costs. Concluding session, Lessons for Developing Asia. We are pleased to introduce Dr. Sitha Ram, Asian Development Bank Institute Fellow, as moderator of the concluding session. He is concurrently visiting professor at the Center for Spatial Information Science, University of Tokyo. He teaches how effective policy frameworks can attract private finance for public infrastructure, advancing quality, efficiency and sustainability. He also serves as an advisor to East Japan Railways Company for India's first high-speed rail project and co-chair of the Special Interest Group on High-Speed Rail in the World Conference on Transport Society. We are also honored to have Hironori Kato, professor at the University of Tokyo, who specializes in transportation planning and policy. With over 25 years of experience in transport economics and travel behavior research, he will deliver the concluding speech for this webinar. Next, we welcome back Dr. Myung Sagong at KRRI will serve as a commentator. Panel discussion. We are pleased to welcome back Dr. Sitha Ram as a moderator of the panel discussion. The first panelist, Professor Sutanto Soodo at University of Indonesia will join the panel. Bringing both academic and practical perspectives, Professor Soodo will share insights drawn from his extensive experience in transport planning, policy and major rail development initiatives. The second panelist, Drive Nguyen Hoang Tung at University of Transport and Communications, Vietnam will also join the panel. He will contribute his expertise in transport and infrastructure development, drawing on extensive research and project experience in public transport, sustainable mobility, and transport policy. The third panelist, Professor Francesca Pagliara at University of Naples Federico II, Italy will also join the panel discussion. Professor Pagliara will contribute her extensive expertise on socio-economic impacts and policy dimensions of high-speed rail development. We now move to the open discussion, followed by feedback survey and closing remark. In this session, we are pleased to have Dr. Sita Ram guide this discussion and facilitate an engaging exchange among our distinguished speakers and attendees. He will also deliver the closing remarks to conclude the webinar. The webinar will begin shortly. Please use the Q&A box for questions and the chat box for sharing thoughts. Please rename your Zoom name to include your name, affiliation, and country.
Thank you. We hope that you enjoy watching the video. It's summarize our previous activities and webinar, that how we how our partner have contributed to our webinar series as of today. And good afternoon, everyone, and a warm welcome back to our high-speed rail webinar series on the policy considerations for national high-speed rail network development, the cases in the Republic of Korea, organized by the Asian Development Bank Institute. And my name is Nguyen, and I will be co-emceeing today's session today with the Chi Wong Lee, our colleague. I will get us started today before handing over to our distinguished speakers. We are honored to have such a diverse audience joining us today from more than 130, with the audience 130 audience, not only from Korea and Japan, but also from Bangladesh, Cambodia, India, Indonesia, Mongolia, Philippines, Thailand, and many more countries joining us today. With this webinar, ADBI is pleased to continue a successful series on high-speed rail that started analyzing the cases from Italy in May 2024, the People's Republic of China in December 2024, the same year, and the Spain in October 2025, and this year, Uzbekistan in April. For this series on the case in the Republic of Korea, we have two parts. Part one of this webinar series was held last month, where we explored the Republic of Korea's remarkable journey in adapting foreign high-speed rail technology and transforming it into the domestic capability. And today, we come to the second and concluding session of this webinar series. And in this final installment, we will shift our focus from technology adaptation to the broader policy and institutional considerations involved in developing a national high-speed rail network. And before we begin, please note that this session may be recorded, photographed, or live streamed. By continuing to participate, you consent to use of your image, voice, or contribution in ADBI publications or other media for external communication purposes. And to ensure a smooth and engaging experience, please be reminded of the following house rule. Please be reminded that there will be a Q&A session after the speaker presentation. So we invite all participants to post your questions on the Q&A box. We will address as many questions as possible. And throughout the session, you are welcome to share reflections or reaction in the chat function at the bottom of your screen. Please keep comments respectful and relevant to the discussion. And if you would like to speak, we also welcome you to, so please use the raise hand icon under the reaction button. We will also have an interactive poll at the beginning of each keynote speech. Please be reminded that these poll questions are intended to gather your views and opinions. There are no correct or incorrect answers, so please stay engaged. And the session is being recorded and will be made available after the event on the ADBI website. So you can take a look at the presentation materials and also recording after the webinar. Before we begin our session, we would like to take a group photo with our distinguished speaker and panelists. And now, speaker and panelists, please turn on, I think you all turn on your camera now. So on the count of three, all right, I think our colleagues also help us to take the photo. Let me, can you stop sharing, Chi Wang? Yep, we will do quick group photo. All right, on the count of three, let's all smile, everyone. 1, 2, 3. I'll do one more screenshot. 1, 2, 3. All right. I hope it's working. Great. All right. Excellent. Thank you, everyone. And thank you once again for joining us today. And now, to open today's proceeding, we are honored to have Professor Bambam Prochongoro, our Dean and CEO of the Asian Development Bank Institute, with extensive experience in the government and academia. Professor Prochongoro brings valuable insights into economic affairs and national development strategies. We warmly invite you to listen. Now I hand over the floor to you, Dean Bamban.
Okay. Thank you, Nia. Very good afternoon, good morning, distinguished speakers, colleagues, and participants joining us from the Republic of Korea, Japan, across Asia, and beyond. It is really my pleasure to welcome you to today's webinar on Korea's high-speed rail experience organized by the Asian Development Bank Institute. I extend my sincere appreciation to our distinguished expert from the Republic of Korea, Indonesia, Italy, Japan, and Vietnam for sharing their valuable insights today. I'm also delighted to see over 130 online participants from across the globe taking the time to join us. This webinar marks the fifth in the ADBI's high-speed rail webinar series on policy consideration for national high-speed rail network development. This fifth episode focuses on the Republic of Korea's high-speed rail development journey. Due to the depth and unique success of each model, this segment was especially structured into two parts. The first part, held last month, examined how the Republic of Korea adopted foreign high-speed rail technology and systematically built its domestic capability to construct and operate national network. Today's webinar is the second and concluding part of the series. It shifts the focus from technology adaptation to broader policy consideration involved in national high-speed rail network development. In particular, we will explore how sustained investment in national R&D enable Korea to develop a self-reliant and commercially viable high-speed rail industry. We will also examine how the country successfully transitioned from a technology importer to a global railway partner, the financing mechanism that supported this transformation, and how emerging technologies like AI are being deployed to optimize operation and maintenance. This discussion comes at critical juncture. Across Asia and beyond, governments increasingly recognize high-speed rail not merely as a transport project, but as a strategic investment in economic integration, regional connectivity, and sustainable development. Against this backdrop, Korea's trajectory offers practical, high-value lessons for nations seeking to build or expand their own networks, including Vietnam, India, Thailand, and Indonesia, who face similar questions regarding technology transfers, financing structures, governance, and long-term sustainability. Reflecting on my experience in public policy in Indonesia, I'm acutely aware of the complex realities developing nations have to face when mobilizing large-scale infrastructure financing and aligning diverse stakeholders and international partners. For Indonesia, at least, I can explain two very important examples. First, when Jakarta was trying to build the very first subway system. Of course, now according to the United Nations data, Jakarta is the largest metropolitan area in the world, but unfortunately, we only have a relatively small line of subway system. And it happened because even though it has been planned since 1990s, but the real construction and implementation and operation of the very first subway system in Jakarta only happened around 2018. So you can imagine there was delay of more than 10 to 20 years. And the reason for delay is simply because even though it has been planned for a long time, but on the financing side, on the investment side, there has been a lot of debates whether this type of subway system is really needed, is really a priority for Jakarta. This because we still have a lot of needs of infrastructure for different parts of the nation. And unfortunately, because the development has been very late, has been delayed quite long, then at the end, Jakarta already has acute congestion that cannot be solved only by developing subway system. But thankfully now, the subway system has been in operation, and now the government is trying to extend the network of this subway system. The second example related to the today's discussion is high-speed railway. And this is different situation because in high-speed railway, actually it has not been planned in advance, but then the President Jokowi, when he came into power in 2014, likes to build the very first high-speed railway for Indonesia, especially connecting Jakarta and the next biggest city, which is Bandung. Since it had not been planned in advance, then there was situation in which government is, struggling to find the source of financing. And finally, although it has had some kind of political turbulence, finally Indonesia decided to ask China technology in high-speed rail to be implemented for Jakarta and Bandung. And today, it has been in operation, but still has a lot of financing issue. At least the government still needs to repay the debt that owed to, especially to China, in order to, of course, to finish the transaction. The point that I can raise as a former finance minister and development planning minister in Indonesia, if you want to invest massively, especially in high-speed rail network, then number one, it has to be planned way in advance. And secondly, everybody needs to give the full political support for this project because the project will not last only 5 or 10 years. It will last maybe 20, 30 years or more because we still expect there will be extension of high-speed rail network. So political support is a must, and it will go through different governments in relatively medium to longer term period. So this is complicated, but again, if we look at the success in Japan, Korea, in China, then we know that high-speed rail network will have a kind of positive influence on the economic development and the movement of goods and people in the nation. So that's why I think today's webinar, I think will help us to understand better about high-speed rail, not only from a technological point of view, but more importantly, from the development perspective, including the financing. So today's webinar brings together an outstanding group of leaders and experts. We are honored to feature our keynote presenters, Dr. Myung Sagwon, President of Korea Railroad Research Institute, KRRI, Professor Yong Sang Lee from Shimonoseki City University, Professor Jin Yong Park from Korea University, Professor Hwa Soo Yo from Korea Advanced Institute of Science and Technology, KAIST, and We will also benefit from the insight of our distinguished panelists, my friend, Professor Sutanto Suhodo from University of Indonesia, Professor Francisca Pagliara from University of Naples Federico II, Italy, Associate Professor Nguyen Hoang Tung of the University of Transport and Communication, Vietnam. I hope this session will foster a rich exchange of actionable recommendations to inform policy design across developing Asia, particularly helping nations move from technology adoption towards self-sustaining domestic capability. Thank you very much and wish you a very productive and engaging webinar.
Thank you. Thank you very much, Dean Bamban, for kindly setting the stage for today's discussion. And thank you for taking your time to join us today, Dean Bamban. And we now move to our first session of the day on the history of high-speed rail technology development in the Republic of Korea from regional perspective. And this session will be moderated by Dr. Min Jong Kim, senior researcher at the KRRI. Dr. Kim, please join me in welcoming Dr. Kim. And without further ado, I'd like to give you the floor, Dr. Kim.
Thank you. It is my pleasure to moderate the first session today. Before we begin the first presentation, we'd like to hear your views through two poll questions. The first question is, what do you consider the most critical factor for a nation to achieve technological self-reliance in high-speed rail? Please select the option that reflects your view. And the second question is, in your country, what is the biggest barrier to developing domestic capacity for complex transport technologies? Thank you for your response. We will come back to the result at the beginning of the Q&A session. Now, it is my pleasure to introduce the first speaker, Dr. Myung Sagong, President of Korea Railroad Research Institute. Dr. Sagong is a distinguished railway engineering expert and research leader. He holds a PhD in civil engineering from Purdue University and has more than 2 decades of experience at KRRI, where he led major national R&D initiative for advanced and sustainable railway system. Today, he will speak on history of HSR technology development in South Korea from regional perspective. Dr. Sagong, the floor is yours.
Thank you, Dr. Minjong Kim. So everyone can hear me. It's okay. All right. Let's get started. Good afternoon, everyone. I am Myung Sagong, president of the Korea Railroad Research Institute. You may call it KRRI. And first of all, I would like to thank to the organizer for giving me this valuable opportunity to share Korea's experience in HSR technology development at today's ADBR webinar. In a relatively short period of time, Korea has progressed from introducing overseas HSR technologies to developing its own high-speed trains and core systems, and is now entering overseas market as well. Today, I would like to focus on this experience and explain how Korea's HSR technology has evolved and what role KRRI has played in that process. So today's presentation consists of 3 main parts. First, I will briefly introduce KRI. Secondly, I'll discuss the R&D process and major achievement of Korea HSR technology. Finally, I will introduce the impact that HSR development has had on the Korean society and the economy. Oh, what is this? Okay, let me briefly talk about the KRI. KRI was established in 1996. Our R&D covers high-speed, conventional, and urban railways, as well as the safety, logistics, policy, and future mobility. We also work closely with the government, operators, industry to bring the research outcomes into the practical use. Over the past 3 decades, Korea has moved from the fast followers to a first mover in railway technology. We developed the technology ranging from the HSR 350X and HM 430X to infrastructure systems such as rail fastening and precast concrete track. And today our research is expanding its next generation HST, hydrogen trains, autonomous operation, and hypertube technology. So this transition shows that the goal of Korea's railway R&D has moved beyond the technology localization toward leading new railway technology and markets. Toward the year of 2030, KRA aims to become a global leader in railway transportation and logistics R&D. Our four strategic directions are spatial innovation, AX transformation, and climate action, and safer and more convenient railways. In short, we are working toward the railways that are smarter, greener, safer, and better connected. So I'd like to move on to the next chapter, R&D history of Korea high-speed rail. This slide shows the Korea's journey over the more than 30 years, from the introducing high-speed rolling stock to localization and commercialization through R&D, and ultimately to overseas export. The KTX introduced through technology transfer from France in the early 1990s created the industrial foundation for the Korea's first R&D program, HSR 350X. This prototype developed through this program lead to a commercial KTX Sancheon. And the operation of KTX Sancheon then supported the second R&D round, which is HM 430X. And this in turn lead to today's KTX Yeom and KTX Cheongyeong. By building our own technological capability through this process, Korea was able to export the high-speed rolling stock to Uzbekistan May of this year. It was not a single project that transformed Korea from an import into an export, but this is a virtuous cycle, and KRI played a leading role in driving this R&D process. In the track and civil engineering field, over the past 2 decades, we have a focus not only on the localizing core railway technologies, but also on taking them through field demonstration and commercialization. As a result, precast concrete slab track has been applied to more than 439 kilometers of the major lines, and more than 2.2 million sets of KR-type rail fastening system has been deployed. In addition, we have continued to expand our technology portfolio to include eco-friendly PSC sleepers that reduce carbon emission, and high-speed turnouts that improve the safety and ride comfort at high speed, and track inspection system that precisely assess the track conditions and improve the maintenance efficiency, and robotized AGT turnouts designed to reduce noise and vibrations. We are currently developing technology to rapidly convert the ballasted section of Gyeongbu high-speed rail to concrete track while maintaining commercial train operation. And next, I'd like to introduce Korea's technical self-reliance and commercialization of the train control system. There's 2 key technical elements: safety and efficiency, and interoperability. The first is the safety and efficiency. A train control system must ensure safety while allowing trains to operate at shorter headway, thereby improving operational efficiency. KTCSM, which is developed under the KRI's leadership, is a Korean train control system for the urban railways. Based on the LTR wireless communication and moving block technology, it enables safe, efficient, and highly automated train operation. It was the first commercialized on the Chilean line in year of 2022 and is now being expanded to other lines. The second is the interoperability. Under the KTSM standard, equipment developed by the different manufacturers can interoperate with one another, and the same principle apply to KTX2 for the convention and high-speed rails. KTSS2 is also compatible with the international standard ETCS level 2. And next, I'd like to talk about the development of the Korean overhead contact line technology. Since 2008, we have developed the 250 kph class systems, followed by the 350 and 400 kph class overhead contact line systems from the year of 2010, and apply them to a conventional and HSR in Korea. These technology continue to be applied to new lines according to their operation speed and conditions. Safety. Railway safety in Korea has developed systematically since Daegu subway fire accidents, which was tragic, which result in 192 casualties. Railway safety in Korea has been systematically managed through the successive 5-year comprehensive railway safety plans. Under the first plan, the Railway Safety Act was enacted with a focus on upgrading aged infrastructure and separating railway crossings. The second plan focused on introducing the safety management system called SMS and platform screen doors. The third plan focused on strengthening the safety of the railway workers, enhancing emergency response systems, and conducting R&D to improve the railway safety. As a result of these efforts, Korea's railway safety level remaining among the highest in the world, alongside countries such as France, Germany, and Italy. Under the first plan, which ran from the 2024 to the 2028, AI-based railway safety training programs are being developed, along with the digital SMS, a data-driven technology for the predicting railway risks. The goal is to reduce the current number of the railway accident by approximately 41% by 2031. Finally, I would like to briefly introduce a new era of the research. The application of AI is already on a top priority worldwide. KRI's research direction for the physical AI focuses on 3 principles. The first is the field-oriented, second is actionable inspection, and third one is enhanced safety and efficiency. By combining wide area inspection using drones with a detailed inspection using robots, our ultimate goal is autonomous maintenance. We call the concept of the DREAM. DREAM is the drone, a robot ensemble for the autonomous maintenance. So I'd like to move on to the final chapter, socio-economic impacts. This slide shows the moving time paradigm shift. Let's look at the how this technology, development and the expansion of the high-speed rail network have affected Korea's society and economy. The most direct benefit of the HSR is dramatic reduction in travel time. The figure compared travel time ranging in 1967 and 2017. In the past, reaching major region from Seoul could take up 9 hours. But with development of the railway network in HSR, major cities are now connected within 3 hours. Looking ahead, our goal is to shorten the travel time even further and connect more major hubs across the country within approximately 90 minutes. Since it launched in 2004, KTX has had a significant socio-economic impact. cumulative ridership has at least 1.23 billion passengers, while daily ridership has grown from about 72,000 to 254,000. The network has expanded
We
from the
have
two
one
lines
minute.
and
Yeah,
22nd
one
to
minute.
eight lines and 77 stations. And for my last slide, this slide summarizes the economic impact of national R&D investment in the railway sector. The production inducement effect is one of the key indicators. It shows that how much additional production is generated not only by the direct within the railway sector, but also the indirect, directly, of course, the related and other industries. So you can see the all the rail sectors and HSR vehicle sectors for the total investment and production induced effect. So, as we have done in the past, KRL will continue to devote its effort to advance Korea railway technology, including HSR. Thank you very much for your attention.
Time.
Thank you very much for your insightful presentation. Before we move to the Q&A, let me briefly share the result of the polls. For the first question, the largest response was government-driven long-term R&D investment as the most critical factor. For the second question, the top response was the limited domestic R&D funding and the testing infrastructure as the biggest barrier. Thank you for sharing your view. Now, let's move on to the Q&A session. If you have a question, please click the raise hand button or type request to speak in the chat box. Let's give our participant a few moments to prepare the question. While we wait for questions from the audience, let me start with one question. Dr. Sagong, Korea had successfully moved from importing high-speed rail technology to developing and exporting its own system. In your view, what are the most critical policy and institutional factors that made this transition possible?
Sorry, Tamin, can you come again? I mean, I
Yeah.
got a little confused of these systems.
Okay. Let me start my question first. So, in your view, what were the most critical policy and institutional factor that made the transition from the importing technology to the developing and exporting its own system?
I think there's several mechanism. I don't know if I get your question correctly or not, but for my perspective, uh, uh, very detailed plan from the government side is very important because when you pursuing the HSR project, for example, in Korea, it took about 15 years for us. At year of 1989, the president declared we will have the high-speed line, and we opened the HSL network at the year of 2004. So it took about 15 years. I think it's a relatively short period of time compared to other countries. But anyway, during when we execute this project, there's a many, how do I say, many discussion, debate, and protest for this project. The key point to make this thing happen is the very strong will and very detailed plans from the government side, and also like the research institute like KRI, maybe kind of helpful for executing this mega project.
Oh, okay, I see. Thank you very much. Um, there is one question from the audience in the chat. I will read for you. The question is from the Yoshino former Dean ADBI. The question is like this. Are all the line of KRFRI in profitable lines? Are there difference in profitable? So this is a question from the Yoshino former Dean ABDI. Please give your answer.
So what is KRFRI?
Uh, uh, sorry. So it is certainly written like this. So,
If it's okay, can I?
oh yes, you can. Yes, you
Okay.
can, please.
Thank you very
Yeah.
much for a very good question. I'm a former dean and also professor emeritus of Keio University. There are many high-speed rail in Korea. Some may be profitable, some may not be a profitable line. So are there differences in Korea? That is number one. If some lines are not so profitable, are there any subsidies from the government? What are those profitability indifferences? Yeah.
As far as I know, we have high-speed lines, 8 lines, and these are the profitable. They gain some profit. But convention line, the operator, we have only one operator, Korail. They lose money. So in total, the Korea is in deficit condition. So but for answering your question, high-speed lines are profitable.
Okay. So there are some subsidies, cross subsidies between
No
the two.
subsidies, no subsidies. Only, I mean, this subsidy is carried by the Korea.
Okay. Thank you very much.
And maybe the third session, the Professor Kim will talk about some financial problem, financial situation in Korea. But because of the frozen ticket price, Korea, the only operator has some difficulties for the maintenance and operation.
Okay. Thank you very much.
Okay, I think we can have one more quick question. Is there any question from the audience? Um,
We have one question, Dr. Kim, in the Q&A box.
in the Q&A box, let me check. This is
No, actually, it's
Sorry.
one more.
sorry, I cannot find the question from the chat box. I'm sorry.
Yep. The question is what impacts this project can have on the environment and natural ecosystem. I think.
I can see what impacts this product can have on the environment and natural ecosystem. This very question is not clear. What impact is project? I mean, high-speed rail project can have on the environment and natural ecosystem. During the construction, we had a severe protest for the environmentalist. For example, when you drill the tunnels, they kind of worry about their groundwaters. For the Cheonsang Mountain, there was a temple on the mountain, and the people in there has a severe against on the execution of the project. But I think I remember that because we have a sufficient technology to solve the problem raised by this environmentalist, so we solved the problem and we passed that section without any problem. So as far as I know, there's not I can say the not, but there's a very minor impact on the environment and ecosystem. So now there's nobody who escalate the problem on their part. So I think we are very clear at this point.
Okay, thank you very much, Dr. Sagong, for sharing your valuable insight with us today. That's all the time we have for the first session. Thank you for our participant for joining the session. Now we will move on to the session 2. Thank you very much.
Thank you very much, Dr. Kim and Dr. Sagong, for your valuable insight into this history session. And I'm sure that it has possibly sparked some question or reflection among our participants, and we may receive more questions in the next session. And the audience, please make good use of the Q&A box. Feel free to post a question in the chat, in the Q&A box. And building on the insight from our earlier discussion, we now move to the second keynote on the history of high-speed rail development, but this time from a global perspective. And to bring along their insights, please join me in welcome Dr. Myung Sagong back to the floor to serve as the moderator of this session. And as the moderator of this session, Dr. Sagong, I'm glad to give you the floor. Thank you.
I have a poll quiz. The first one is when partnering with the international HSR providers, what should the developing nation prioritize the most? So there's a 4 answers. You can pick it up. And I will lead to the second questions. Which state of Korea's four-stage development model is most urgent for middle-income countries today? Also, there's 4 answers, so you can pick it up. And we will discuss the most selected answers at the Q&A session. Now, let me briefly introduce Professor Yong-sang Lee, the second session presenter. Professor Yong-sang Lee is the professor at the Shimonoseki City University, Japan. And he previously served as a vice president of the Usong University, president of the Korea Society for the Railway, and chair of the Korean Railway Heritage Foundation in Korea. He was also editor-in-chief of the 20 years history of the Korea high-speed rail. Early, he worked as a senior researcher at KRI, and his research focused on high-speed rail policy, railway technology, transport planning, and railway history. Professor Lee, the table is yours.
Yes, thank you. Thank you for inviting me. Good afternoon, everyone. My name is Yong-sang Lee from Shimonoseki City University. Actually, I'm Korean. Thank you very much for giving me this opportunity. Today, I would like to talk about Korean high-speed rail development on the title From Imported Technology to Global Market Position. Korea's high-speed rail development model and international implication. Sorry, the next slide. Could you see me? How about the next slide? It's okay.
We can see the slides.
Can you have to share that again?
Yes, sorry. Can I?
Yeah, you can start sharing again.
More one time? It's okay? Yes, okay. Can you see me?
We don't see the slide yet.
Oh, really? Sorry. How about that? No?
Do you want us to share the slide for you?
Yes.
All right. Jiwon, can you help to share the slide? And then when you move to the next slide, just let us know, and then we move for you. And thank you, Professor.
Yes, I will check it. It's okay?
Oh,
No?
yeah. Professor, we can see the slide. Yeah.
Okay, thank you. Sorry, it's my trouble. Yes, my presentation focuses on development process of Korean high-speed rail system. Rather than simply describing the history of KTX, I would like to emphasize one important question. How did Korea move from importing high-speed rail technology to developing its own technology and eventually becoming an international railway supplier? I will explain this process from the perspective of technology transfer, localization, innovation, and overseas safety. So from imported technology to global market position. This slide summarizes the main argument of my presentation. There are four important elements in Korea high-speed rail development. First is technology transfer and learning. Korea did not regard import technology simple as something to operate. Technology transfer become the starting point for technology learning. Second is indigenous technology development. Through continuous research and development, Korea developed technology which is represented by the HSR 350, Korea Sancheon, and HELM 430. So the Korea gradually developed the capability to provide not only trains but also operation, maintenance, training, and localization. Finally, the process was supported by cooperation among the government, railway operator Korea, manufacturer ROK, universities, and research institute KRLI. Therefore, Korea's development can be understood as a transition from technology import to learning, to localization, and finally to innovation and internationalization. Korea's experience particularly important from the perspective of technology catch-up. Initially, Korea depended highly on foreign high-speed rail technology. However, Korea did not remain simply a technology importer. The country gradually absorbed, adapted, and internationalized imported technology. Therefore, the main research question is, what made this transition possible? I argue that the technology transfer itself was not sufficient. Human resources development, domestic research capability, institutional coordination, and long-term government commitment were so essential. This experience may provide useful lessons for countries that are currently developing high-speed rail system. Why did build this high-speed railway? Why did Korea decide to construct high-speed rail? There are several reasons. The first was rapidly increasing transportation demand. Korea experienced that rapid industrialization and urbanization, and congestion on major transport corridor became increasing seriously. Second, high-speed rail was closely connected with Korea's economic development strategy. Connecting major cities more efficiently was important for both possible passenger mobility and national economic activity. Third, high-speed railway was expected to contribute to regional development by improving accessibility between Seoul and other regions. Therefore, the Korea project, KTX project, was not simply a railway project. It was a strategic national infrastructure project closely linked with transportation policy, regional policy, industrial development, and Korea's long-term economic strategy. This slide particularly important for understanding Korean model. When Korea introduced high-speed rail, it first defined its long-term transportation requirement and then evaluate competing foreign technology. Eventually, Korea selected the French TGV system. However, the important point was that Korea did not simply purchase trains. Technology introduction was combined with technology transfer, overseas training, domestic research and development, and localization. Korea engineers received training abroad, while universities, research institutes, and manufacturers accumulate technological knowledge domestically. In other words, procurement policy and industrial policy was closely connected. This is one of the most important characteristics of Korean model. Korea used a major infrastructure project as an opportunity to build its own technical and industrial capability. The next stage was the transition from imported technology to indigenous innovation. At the beginning, Korea engineers learned from French technology and gained practical experience with the high-speed rail system. But this knowledge was gradually accumulated within Korea. University trained engineers, research institutes conduct R&D, and domestic manufacture increased their technological capability. This process eventually led to development of Korea's own high-speed rail technology. Important examples include HSR 350X, KTX 3000, and radar HAMU 430X. The key point is that localization did not occur immediately. It was the result of long-term investment, learning, research, manufacturing experience, and institutional cooperation. Therefore, technology transfer should be understood as the beginning of the technological development rather than its final goal. Today, Korea has developed capability across most areas of high-speed rail development. This includes train design, infrastructure, operation, maintenance, digital system, and integrated railway management. This is important for Korean international position. Korea does not necessarily compete only by selling rolling stocks. Instead, Korea can offer a more comprehensive developing package, including technology transfer, workplace training, localization, operation, and maintenance. This can be attractive to countries that want to not only to purchase trains, but also to develop their own railway industry. Therefore, Korea can position itself as a comprehensive railway development partner in global market. Korea's competitive advantage. Korea has several competitive advantages. The first is collaborate innovative ecosystem. Government agency, railway operator, manufacturer, universities, and research institutes have accumulated experience through cooperation. The second advantage is system integration. Modern high-speed railway require the integration of infrastructure, rolling stock, signaling, operation, and maintenance. Third, Korea has strengths in digital railway technology, including smart operation, productive maintenance, and database management. Finally, Korea has more than 2 decades of practice KTX operation experience. This combined capability can strengthen Korea's competitiveness in international railway process. What lessons can developing countries learn from Korea? I would emphasize 4 points. First, technology transfer should focus on capability building, not simply equipment acquisition. Second, countries need what we call observative capability, the ability to understand, adapt, and eventually improve imported technology. Third, large infrastructure projects can also be used as the instrument of industrial policy, and local company should participate in manufacturing, maintenance, engineering, and research whenever possible. Finally, the technology development requires long-term commitment. The Korea experience shows the successful technology catch-up requires cooperation among government, industry, railway operation, universities, and research institutions. Therefore, the most important question is not simply which technology should we buy? The most important question is what capability can we build through this project?
Professor Lee, 1 minute left.
Yes.
Please.
Looking toward the future, the Korea needs to move beyond the traditional model of railway import. The last slide, I will show you the last slide. Let me conclude. Korea's high-speed rail development can be summarized as a three-stage transformation. The first stage was technology import. The second stage was capability building and localization. At the third stage is the transition toward becoming a global railway partner. The development HRS 350 and HEMU 430 demonstrate how important technology can become a foundation for individuals innovation. Finally, I will make short conclusion. Korea's high-speed rail journey is a story of transformation from importing technology to learning it to creating our own and finally to sharing it with the world. Thank you so much for your attention. Thank you.
Thank you, Professor Lee. We have one question from the audience. Can you see the question? I read it. In your opinion, what is the priority of the technology development capability needed to be prioritized to be acquired? And how to maintain the continuous capacity building across academia and local railway industry?
Yes, thank you. Thank you for your good question. So I think the important thing is the cooperation. So in Korea's case, our government has a strong leadership, and Korea government has make the long-term vision project. Based on that, the government made the governance system. They make the government made some institution and some academic society. So they coordinate the things to develop to make the high-speed railway. Is my opinion. Okay.
Thank you. Because of the time, I think limitation, we have to move on to next session.
Okay, it's okay.
You want to highlight the result of the poll?
Oh, where is the result?
Okay, I'll share the result so you can show quickly.
Yeah, the results of poll, the most selected answer is a comprehensive technology transfer and human capacity building. Is the most selected answer. Thank you.
We have one more question, number
Okay,
two.
second one. Yeah, second, we have two answers. They got the same number of selection. The first one is strategic planning and technology selection. Second stage is technology transfer and localization program. Thank you for your contribution.
Thank you very much, Professor Yong-Sang Lee and Dr. Myung-Sagong, for your valuable insight into the global perspective and lessons from Korea and how developing countries can adapt to modernize their railway system and through a sustainable partnership and knowledge exchange. The audience, if you have a question later on, we just want to inform you that we have an open discussion at the end. So please keep your question and post your question at the time as well. So. And now we will now proceed to the third keynote, the challenges and issues in the financing high-speed rail in Korea. The session will focus on the financial instrument, the institutional structure used to build a Korea high-speed rail network, tracing its evolution from the public R&D grants and stage-backed financing to modern public-private partnership model for global export. And it's my pleasure to welcome Professor Yong-Sang Lee back to the floor, and this time as the role of moderator for the session. And over to you, Professor Lee.
Yes, thank you. Thank you for your this session. I would like to introduce Professor Jin Young-ba. He is a transport and smart mobility specialist within over 25 years experience in transport policy, infrastructure financing, and international development. He got a PhD Imperial College in London. It was the famous university in the world. And currently he served the ADB. So actually the poll, I cannot handle it. So would you help me? And
Sure.
yes.
Okay, I'll launch the post. Just let me. Okay, I'll allow the panelists to vote, and now I'll launch. Can you see the question, the post questions now, Professor Johnson?
Yes. So how about the session 3, the 2 questions? Would you pick up the answer? This 1 and 2 questions. Would you pick up the answer? And then we will, after the presentation, based on that, we will discuss it. It's okay?
Yep. I think we highlight the result during the Q&A session. So now I think
Okay.
Professor Jin Young-Pak can start your presentation.
Yes. You're welcome to Professor Jin Young-Pak. Thank you.
May I share my presentations? Okay. Okay. Can you see my presentation?
Yes, we can.
Okay. Good afternoon from Korea. I'm Dr. Jin Young Park. It is nice to meet you, and it is my pleasure to have opportunity to share the financing Korea's high-speed rail information with you today. Let me start the basic standard of Korea's railway infrastructure financing. Originally, Korea followed the principle of public sector development and operation of rail infrastructure with a clear separation between the transport sector and urban development sector. Actually, some of you may know about Rail Plus property model of Japan and Hong Kong SAR, but it's quite a unique model, and it's quite good for financing the big infrastructure like high-speed railway. But in Korea, definitely, as I mentioned, we have a clear separation between a transport sector and urban development sector. Korea has different guideline for different category of railway system, particularly for high-speed rail.
I'm sorry for interrupting, Professor Park. Can you make it full screen? I think it's in the presenter mode now.
Okay. Right. Okay. Sorry. Is okay. Is it okay?
We can see, but we see both the presenter screen, 2 screens. So can you?
Okay.
Yeah, you can try again if in.
Let me try again. Okay.
Sure.
Okay. Sorry for.
Yeah, I think it's good. Can you start full screen?
Okay. Yeah. Is it fine?
Yes, it's working well now. Thank you.
Okay. So for high-speed rail, actually, central government and local government had a 50-50 rule. So national treasury shares 50% of overall cost, and then local or like the PPP model, other shares 50% 40%. However, for conventional rail, central government is funding the full amount of construction cost. But for metropolitan rail or urban rail, it has a different share of central government and local government. Korea has unique or dedicated funding for transportation infrastructure named as the Transportation Facilities Special Account, TFSA. It was established in 1994. Before 1994, mostly Korean government has a road account, special account for road construction and rail budget and other budget for airport and port. But in 1994, Korean government integrated the whole this budget system as one special account as a TFSA, and it provided stable funding for Gyeongbu High-Speed Rail Phase 1 and Incheon International Airport. For within the TFSA, rail account shares is about 40% and road account 40% and others. Mostly this TFSA comes from the fuel tax like the gasoline and diesel. Let me briefly share the financing for high-speed rail phase 1 and phase 2. For phase 1, that central government has 35% budget share, and then Korean National Rail, the agency self-financed up to 65% of cost. But after that, because of accumulated burden for the agency, Korean government changed it to 50-50. For why the reason of 35 and 65 share for high-speed rail phase 1 was mostly caused by the Asian economic crisis in 1997, and then Korean government national budget was strictly controlled by IMF. So in that time, it is not easy for increasing or providing the national budget for similar national project. That's the reason for the first phase share. But after that, we changed it to the more reasonable budget of 50-50. As you know, Korea's rail sector separates infrastructure from operation. So we are in a vertical separation model like the other some European country. So in Korea, the operator, Korea, paid track usage fees to Korea National Railway, and Korea National Railway repaid the principal and interest on construction bond from this track usage fees from operation. I will explain detail these two financial numbers in next slide. So overall, profitable yet capital impaired. This the two railway-related agencies' current situation. For example, Korea National Railway. The Korean National Railway has about 20 trillion Korean won construction bond liabilities, and still the Korean National Railway pays interest and then bond. So still, even that the Korean National Railway has some net profit because of construction bond liability. Still, the Korea National Railway has negative revenue financial issues. Regarding Korea, the operator has a chronic deficit structure. I think there are three key issues. One is below cost fared. I will compare Korea's fare level with the other international cases later, but generally Korea has relatively cheap fares. And then inadequate PSO compensation, public service obligation. As Dr. Sagong mentioned, high-speed rail is profitable, but for other conventional rail is not has a big deficit. Because of it, Korail has internal compensation for high-speed rail and conventional rail operation, and then that PSO compensation from central government is not enough. And then track usage fee burden. As I mentioned, Korail pays 34% of KTX revenue to Korea National Railway as track usage fees. And then it is a kind of structural cost burden on its most profitable service of high-speed rail. It's just some it's information for overall fare level. So Korea's high-speed fare is relatively cheaper than other international case. So now there are a lot of international demand for high-speed rail, and Korea has tried to shift toward an export-oriented PPP model. So we are combining the technology and the financing. So one example was the Korea Overseas Infrastructure and Urban Development Corporation has PPP with Hyundai Rotem, which is manufacturing company of high-speed rail. And then so with this kind of system, Korea tried to export Korean highway system to other countries. Let me briefly summarize some implications for developing countries. So as Korea has one important thing is first earmark purpose account dedicated to transportation infrastructure. And I'm not sure it could be a good one, but infrastructure operation separation is a Korean system. And phased cost sharing ratio. Because of first phase,
You remain 1 minute.
yeah, expensive self-funded structure, we changed it to lessen the burden for the agency. And then we try to develop PPP-based export system. But I think still Korea has a limitation of this kind of PPP model. And in longer terms, maybe some countries may consider rate plus property model, then clear segregation of rail and property system. Thank you for listening my presentation on financing system of high-speed rail in Republic of Korea. Thank you.
Thank you. Thank you, Professor Brown. Thank you very much for your excellent presentation. Now, I would like to open the floor for question. Do you have any question using the chat box? How about that? His presentation is so interesting. Okay.
Professor
So,
Yosali, we have several questions.
oh, really? Yes, so,
Can you check whether any relevant
yes,
question?
okay. Okay. Professor Park, can you hear the chat box? Can you see the chat box or not?
I can, yeah, I can check it, yeah.
Yes. There are several questions about. So, Maria Helena, how long did you take to pay for all complete project? So something basic. How about that?
Okay, and actually, as I mentioned in my slide, still national Korean National Railway is paying for that bond. So I'm not sure how long it would take. Always there are discussion to improve the fiscal situation of Korea National Railway, but still it is discussion. So it is quite important whether we would segregate the high-speed rail construction bond from current fiscal system of Korea National Railway, but still it is under discussion, and I'm not sure how long it would take for clearing all this bond.
Okay, thank you. Yeah. So is it available to one more question? So Nanyan, is okay?
Yes, we still have time. Yes, you
We
can
have
invite.
one more time.
Yeah.
One more question. Yes.
Yes.
So what lessons from Korea's debt management approach are most relevant for developing countries with major infrastructure needs but limited physical space. So how about that? So
Okay. Okay. For debt management, let's say two points. One is managing revenue, and second is managing the cost. For revenue, still I mentioned Korean high-speed rail fare is relatively cheaper than other countries. So we can raise the high-speed railway fare similar to other countries, right, for increasing the revenue. But it's related to a policy and philosophy of a transport system, right? So whether we are focusing on economic point, or we are a point on inclusive providing of mobility option. Each country has a different point of view, so I'm not sure which is the best one, but you need to consider which is the best fare level for each country. And then for managing the cost and debt, as I mentioned, there is one option to segregate construction debt from current fiscal system of railway operator or infrastructure management. That could be one option to clear everything, right? But still, Korean government and Korean system is under discussing of which is the a better one. But we can find the option between these two way of clearing the debt or including debt in fiscal system. I'm not sure which is the better option, but we have two options and we need to find the best way to clear or including construction theft in our or in your fiscal system.
Thank you. So,
Professor
yeah,
Yosanli, we
okay.
still have some time for the Q&A session, and we have asked participants to rate the question, and we have to see the top question. Kind of two people vote for that. Can you also answer the question from Akshay or Togo? You can pick up one of the question. Can you see the question, Professor Park
Yes,
and Professor Lee?
yes. There are so many questions about
The last two one. Yeah,
yes,
we have received more and more questions from participants as of now. The
yes.
two last one. Professor Park, you can select one of them and answer and help to answer. We still have 1 minute for this
Okay.
session.
So how about the last one? How would you rate the 50-50 model today, given different macroeconomic outlook and physical space over the years? What balance should developing countries keep in mind regarding infrastructure investment?
Okay. To be honest, let's say how Korean government set up the 50-50 rule, right? That's I think the key point. I do not think it's based on infrastructure condition or depreciation or the real-time assessment of overall railway system. It's more like the deal between central government and local government. So one actually realistic or scientific option of finding the best cost sharing rule is should be based on the overall railway infrastructure operation cost and then infrastructure cost. So it is not the 50-50 is not the number based on economic system. It's more like the political numbers based on central government and local government, right? So let's say we need to find the best number, whether it's the 50-50 or 40-60 or 30-70. It's based on clear review and study for each country, right? So it is depending on every country condition. Not we cannot propose some specific number is best for you, right? So you need to study about this one. Yeah.
Okay, thank you. Yes, we have no time, so thank you very much for your excellent discussion. Thank you.
Yeah, thank you for your excellent time management as well. We end
Okay,
actually
thank
on
you.
time. Thank you again, Professor Yong Stanley and Professor Chin Yong Park,
Thank
for your
you.
valuable insights into the public R&D investment frameworks and debt management structure and modern public-private partnership models that make career high-speed rail financing viable. And we will now take a 5-minute break before continuing the remaining session of today's webinar. And we will have one more session and a panel discussion and open discussion. So for those questions that we have not answered, so we may request our speaker during your time, if possible, can you help to write the answer, type your answer to the audience question if it's possible on your side. And for participants, we encourage you to stay on Zoom during the break. And please take this time to relax, stretch, or grab something and to drink or eat. And we will resume promptly at 4:25 Japan time in the next 4 minutes. All right. So see you again soon, everyone.
Thank you.
Okay, thank you.
Welcome to the High-Speed Rail webinar series on policy considerations. House rules. Please ensure safety control. As a technology importer into a global university and editor-in-chief of the 20-year history of KTX, Professor Lee will share actionable frameworks for international infrastructure, advancing quality. Head of Civil and Environmental Engineering at KAI. 4. Institutional arrangements for operation and maintenance of high-speed rail in the Republic of Korea. This session explores Korea's tripartite governance model, KRNA, Korail, SR, Hyundai Rotem, and digital maintenance innovations. Session 4 Moderator, Dr. Jin Young Park at Korea University. Keynote speech 4 Speaker, Professor Wasu Yo, Head of Civil and Environmental Engineering at KAIST. An expert in smart mobility and AI-driven transport, Professor Yo will explain how condition-based predictive maintenance reduces HSR costs. Concluding session, Lessons for Developing Asia. We are pleased to introduce Dr. Sitha Ram, Asian Development Bank Institute Fellow, as moderator of the concluding session. He is concurrently visiting professor at the Center for Spatial Information Science, University of Tokyo. He teaches how effective policy frameworks can attract private finance for public infrastructure, advancing quality, efficiency and sustainability. He also serves as an advisor to East Japan Railways Company for India's first high-speed rail project and co-chair of the Special Interest Group on High-Speed Rail in the World Conference on Transport Society. We are also honored to have Hironori Kato, professor at the University of Tokyo, who specializes in transportation planning and policy. With over 25 years of experience in transport economics and travel behavior research, he will deliver the concluding speech for this webinar. Next, we welcome back Dr. Myung Sagong at KRRI will serve as a commentator. Panel discussion. We are pleased to welcome back Dr. Sitha Ram as a moderator of the panel discussion. The first panelist, Professor Sutanto Soodo at University of Indonesia will join the panel. Bringing both academic and practical perspectives, Professor Soodo will share insights drawn from his extensive experience in transport planning, policy and major rail development initiatives.
You are. Let's resume our session.
Okay, welcome back, everyone. We are now moving on to the fourth session of today's webinar.
Rail development.
So could you all kindly return? And if possible, if y'all could turn on the camera, that would be great for more engaging interaction. We're now moving on to the fourth session of today's webinar, which is on institutional arrangements for operation and maintenance of high-speed rail in Republic of Korea. This session will be moderated by Professor Jin Young Park. This session will focus on how AI-based digitalization, continuous condition monitoring, and digital twins transition railway O&M from receptive pairs to predictive condition-based maintenance, optimizing long-term lifecycle cost and operational safety. Professor Jin-Young Park, you'll be moderating this session, so the floor is yours.
Okay, thank you for Jiwon. Welcome back to seminar. And actually, I tried to answer the question in previous session. So I tried to my best to answer every question. And let me go to the session 4. Let me introduce Professor Hwasu Yeol. He is a professor and head of the Department of Civil and Environment Engineering in Korea Advanced Institute of Science and Technology. And he is expert in AI-based transportation system, smart mobility, and advanced data analytics and transportation network optimization. So he got his PhD from the University of California, Berkeley. And now, actually, he is currently served as an associated editor of Transportation Research Policy, Emerging Technologies. So let me introduce, let me welcome the Professor Hwasu Yeol.
Thank you, Dr. Park, for your introduction. And I want to express my thanks to the ADBI for giving me this opportunity of sharing my opinion to the experts from our neighboring Asian countries. So good afternoon, everyone. Today I will discuss AI-based digitalization for railway operation and maintenance. The key message is that AI should not be introduced as a technology showcase. It should be introduced as a practical way to move railway maintenance from reactive repair to predictive, condition-based, and optimized operation. I will focus on how developing railways can adapt to this transition in a cost-effective way. Let me begin with the central question. How can developing railways introduce AI into O&M cost-effectively? This is not simply a question of buying sensors or software. We need to decide which maintenance strategy should be selected first, so where AI creates the strongest business case and what foundations must be built before scaling. The goal is safer and more efficient railway operation, not just more technology. The most important reframing is this. Digital railway O&M is a maintenance strategy transformation. Field signals from IoT sensors, inspection trains, CCTVs, and operational systems must be integrated into a data hub and asset registry. From there, AI can diagnose abnormal conditions, predict remaining useful life and failure windows, and support work orders, crew planning, and possession planning. AI creates values only when prediction changes on actual maintenance decisions. The Korea's automatic inspection trains provide a useful example of how data collection can be shifted from periodic manual inspection to continuous and operational coverage. By installing inspection equipment on passenger trains, track, the catenary, the signaling, communications, and other facilities can be checked during service. The strategic value is not only inspection efficiency. The frequent route-wide measurement create condition histories that become the data acquisition layer for AI diagnosis, prediction, and optimized maintenance. The second Korean case is AI-based condition-based maintenance. The CBM monitors asset condition during operation and uses AI to predict possible failures. Korail expanding CBM data analysis centers So they already have 3 centers in South Korea, and they want to expand these, that's data analysis centers. And they want to expand their maintenance analytics capability. And also, the next generation KTX EM, that they uses IoT sensors on key components such as axle bearings and main transformers. The important policy message is that the CBM should be framed as a platform capability, not as isolated analytics pilot. So where should AI start? The best starting point is where risk, cost, and data readiness align. Assets should be prioritized when failure has serious safety concerns and consequences. And so when it causes a major service disruption, when it requires a costly and infrequent manual inspection, and so when they have enough sensors or historical data to support modeling. Equally important, there must be clear intervention options. In other words, we should start with critical, the failure-prone, or high-cost assets, not with the network-wide AI deployment. Different maintenance strategies have different cost structures and capability requirements. The first one is the reactive maintenance. It has low upfront cost, but high disruption and safety exposure. The second option is the time-based maintenance. It can improve predictability, but may create over-maintenance. The third option is the predictive or condition-based maintenance. It can reduce failure, but it requires high-quality data, AI capability, the governance, and organizational readiness. Therefore, the recommendation is not to jump directly to CBM everywhere, but to upgrade by asset criticality and readiness. This slide shows the overall concept of an AI predictive maintenance platform. At the top left, IoT data and facility data can be acquired and stored in a data hub. Then, using this data, AI diagnostics classify abnormal states, and the prediction models can estimate the future condition of assets. And at the bottom line, the BIM, the building information modeling for the infrastructures, and the asset twin can provide the spatial and asset context. Simulation, it can evaluate the future impacts, and finally, the AI-based decision-making converts these results into maintenance actions. This is the closed feedback loop that makes predictive maintenance operational. A national railway network should not be treated as one uniform maturity level. The appropriate strategy depends on the supposed asset criticality and capability maturity. Low criticality assets with basic capability may begin with reactive maintenance and better records. The high criticality assets with basic capability may need TBM, time-based maintenance, plus targeted sensors. As you can see at the top right corner in the figure, when capability and asset criticality are both high, then predictive CBM, the digital twins, and optimization become appropriate. The policy implication is that you have to select the strategy by corridor and asset class. So Korea can serve as a reference model. But the transferable lesson is not to copy technology wholesale. The important lesson is the sequence of capability building. So automated inspection, continuous condition data, the CBM analytics, AI prediction, and finally, maintenance decision support. Korea is relevant because it has dense, high-speed, and urban rail operations, strong ICT and rolling stock manufacturing capability, and expanding inspections and CBM infrastructures. These elements can be packaged into modular solutions for countries at different maturity levels. For developing countries, the key is to build a minimum viable digital railway before attempting full predictable maintenance. In the first 6 months, the priority is asset inventory, the common identifiers, and priority use cases. From 6 to 18 months, operators should digitize work orders, strengthen TBM disciplines, and build a data hub for the MVP. From 18 to 36 months, they can introduce CBM analytics, digital twin pilots, and risk-based planning. Beyond that, simulation and optimization capability can support network-wide scaling. The first foundation is a data hub and common asset model. So without trusted asset data, so all pilots do not scale. The railway operators need common assets, asset IDs, the location referencing, and integration of sensor, inspection, EAM, ERP, weather, operation, and incident data. They also need both real-time event processing and historical analytics. The practical deliverable is an asset-central data lakehouse, an event bus, and a master asset registry for priority assets. Once data are available, they must be converted into the trusted diagnosis and the prediction. The raw signals and inspection record feed the AI diagnosis, to which should provide for type, the confidence, and supporting evidence. Prediction models then estimate the failure risk, remaining useful life, and lead time. These outputs must be tied to interventions threshold and work orders. Railway AI must combine data-driven models with engineering rules, human validations, and continuous monitoring of false alarms, lead time, and model drift. Prediction becomes useful only when it supports decisions. The asset digital twin answers what asset, where it is, what condition it is in, and what risk it carries, and what action is required. Simulation evaluates failure consequences, the maintenance windows, crew, part, depot capacity, and climate risk. Optimization prioritizes the interventions on the safety, budget, timetable, workforce, and inventory constraint. The goal is not autonomous maintenance, but auditable decision support with explicit human authority. Implementation challenges often determine success, so more than algorithms. Data and integration problems include fragmented legacy systems, inconsistent asset IDs, and sparse failure labels. Safety and cybersecurity require model validation, fail-safe procedures, and protection against a large attack surface. People and process issues include false alarm fatigue, the tacit knowledge capture, and the human approval workflows. Procurement must also avoid the vendor lock-in and protect data rights. These foundations must be built together with the technology. The policy recommendations are threefold. The first, to build interoperable railway data infrastructure before scaling AI. This means asset data standards, open interfaces, the cybersecurity, data rights, and procurement requirement. The second recommendation is that you have to prioritize predictive maintenance by asset risk and readiness. Select high consequences, high cost, data-ready assets and with clear intervention options. The third recommendation is that build the safety governance and the human capability together with technology, including alert escalation, validation, human approval, training, model training, and update process. Let me close with the main message. AI should be judged by the safer operation, the fewer failures, and the lower life cycle cost. The cost-effective AI adoption for railway O&M means starting from operational pain point and asset risk, matching the maintenance strategy to country and corridor maturity. So building the sixth capability as one closed feedback loop, and scaling through phased implementation rather than isolate pilots. The question is not how much AI can deploy, but which. AI-enabled decisions improve safety, reliability, and life cycle cost. Okay, thank you for listening.
Thank you, Professor Yer. Your exact presentation within 15 minutes. So let's go for a Q&A session. Before getting your question, let me check the polls for the session 4. There were two questions. One is which institutional government model is most effective for managing high-speed rail system? That was the first question, and 52% of answers on tripartite model, right? Separating infrastructure ownership, passenger operation, and rolling stock maintenance. That's the largest answered question. Answered, and then second question was what technology hold the highest potential to optimize long-term HSR O&M cost. The 60% of participants answered AI-driven predictive maintenance and sensor data analytics. That's the highest potential to optimize long-term high-speed rail O&A cost. That's the poll and your answers. So thank you for your participation. Okay, let's go for the Q&A. Okay, still there are a lot of questions regarding the previous one. Okay, so I have some overall questions in AI implementing maintenance system. Professor Yeo, you mentioned that the importance of a data foundation for railway high-speed railway maintenance system. Do you have any specific operational strategies or a government structure which enable this kind of a data issue solving?
Okay, so actually the data is the most important part and the most difficult part. So when you want to implement AI in the railway operation and management. So we have some kind of experience of the CBM. So maybe the Corail also has the, the CBM data analysis center, and also, the KTX EUM. Okay, so, so we have installed, the CBM. So meaning that, for 7 critical parts, so like there's some rolling stocks and there's some bearings. So we installed some sensors. But so to have a really the nice CBM and the AI the predictive maintenance, we have really huge number of the data, and this data. So I think it takes at least there's some more than 10 years in acquisition of those kind of the data, because so we have to observe the full life cycle of the data. So so if the the company is really a new the state, and also the new the companies will be deteriorating. So we want to observe all the deteriorating process until the failure. So we need some kind of the big, the sustainable data analysis center that can acquire all the life of this components. And this is the first one. So from this the perspective, I think that the core rails, the current the direction is really good, because they already have 3 CBM data analysis center. So and but still this is still the data gathering stage. But after this gathering stage, so we have to move into the next stage. So we have to make some kind of the prediction capabilities. So and we have to make more decision-making capabilities. So we need a kind of the full scale, the CBM, the decision support center at the national level, or sometimes we have to collaborate with other, other countries too, because so still we need a huge number of the data for the deterioration processes. Okay, this is my view. Yeah.
Okay, thank you. There are some question in the screen, so I hope you would answer all these questions, right? So also
Okay.
I will I will try. So one more question of implementing AI for railway maintenance, because of when we are implementing AI, there are two issues: how we can trust the result of AI, and then what that black box issues in AI, right? So how we can trust the AI result and then implementing this result to actual railway maintenance system.
Mhm. Yeah, so actually, I do not believe in AI, but nowadays the capability of the AI is growing fast and fast. So we need some kind of the experience. So we need some kind of the expert. So it means that we do not want to make a black box structure that can predict everything. So we have to make it, the phase by phase, or the component by component, or step by step. So meaning that we want to check the deterioration process, how the variance will be deteriorated. And so we have to build the deterioration model using the AI. And after confirming, there's the AI as confidence, and then we can use that kind of the models. So we have to, the decompose this kind of the structures one by one, as until that we can, the trust, the result from the AI. So we need a high level expert, and we need a large, the huge number of the data. And so we have a really good step that can, they handle AI very well. So I think, yeah, this might be the answer for your question.
Okay. Final one question. Actually, railway maintenance is quite labor intensive area, right? So how we can shift from this labor intensive system to AI based system, and also there might be the issues for labor union, right? How we can resolve this kind of issues?
Or yeah, that's a really difficult issue. So as you know, there's most of the the maintenance, the workers, they just use some kind of the old tools and the old ways of the doing the maintenance. They are doing the visual inspection, but here, so AI is to help those kind of the inspectors and the maintenance workers, so that that they can get a lot of benefit, by introducing the AI so in their work.
Okay, thank you for your presentation and answers. So I hope it's quite useful for the developing countries' railway maintenance. So let's wrap up the session 4, right? I thank you for Professor.
Yeah, thank you very much.
Thank you, Professor Jin Park and Professor Ha Soo-ya, for enlightening us on the advanced digital maintenance tools like AI and digital twins that ensure the long-term efficiency of high-speed rail operations. To close the presentations part of our webinar, we are honored to hear the concluding reflections of the distinguished speaker. It is now my pleasure to introduce our moderator for this session, Dr. Sridharan, ADBI Fellow and Visiting Professor at the University of Tokyo, and also co-chair of SIGA4 WCTRS, the World Conference on Transport Research Society. Dr. Sridharan brings 3 decades experience in shaping infrastructure policy, supporting project implementation, and regional cooperation across Asia. Please join me in welcoming Dr. Sridharan.
Thank you, Jiwon. It's my distinct pleasure to chair this session, and it's my honor to now welcome Professor Hironori Kato at the University of Tokyo. He was already introduced, but he has been playing a pivotal role in each of these webinars, quite challenging, but doing it exceptionally by reflecting on the lectures and the keynotes, and then summarizing with some lessons for Asia. So without any delay, let me welcome, and please join me to welcome Professor Kato for his final concluding reflection. And then we will have open discussion after him. Please go ahead, Professor Kato.
Thank you. Thank you, Dr. Sitaram. Good afternoon, everyone. This is my great pleasure to make some concluding presentations. Let me open my file. Oh, cannot open it. Wait a moment. Yeah. Oh, yes, this one. All right. I hope you can see my slide. Right. Okay. Concluding session, lessons for Asia. I'm Hironori Kato from the Department of Civil Engineering, the University of Tokyo. Today, we had 4 keynote speech regarding the high-speed rails in Korea. I really enjoyed those presentations, and they are very informative. I learned a lot. I would like to first summarize what we can find from those presentations. First, presentation was made by Dr. Sagon. He talked about the history of high-speed rail technology development in South Korea from regional perspective. He first explained overall issues of Korean high-speed rails. They developed systems including track components, signaling technologies, energy management, safety management in high-speed rails. They call KTX. He also mentioned that the great impact from the introductions on operations of KTX. It has a huge socio-economic impacts on the local and also national macroeconomies. And particularly, he highlighted the significant contributions of KTTI, particularly in terms of research and development in terms of railway industries. And also, quite impressively, KTTI contributed to the also international relationship, including the export the technologies based on KTX to other countries. And also they did many joint research with various institutions in the world. In the second keynote speech made by Professor Lee, he talked about the topic from imported technology to global market position. Again, it is very interesting presentations. I found that the motivation of high-speed rail introduction in Korea's transport demands, economic growth, regional developments, plus national developments. These are all quite common across all developing countries or economies who want to introduce high-speed rail. So we learned, yes, the same motivations. And also, indigenous innovation. I think that is a quite unique characteristics in Korean high-speed rails. Of course, they first imported technologies from France, but they made many efforts to develop domestic capacity building, and finally, they successfully did the domestic manufacturing. He also highlighted the Korea's advantage: collaborative innovation ecosystem, system integration, yes, digital technologies, plus, and sustainable operations. He, yes, also summarized the lessons for developing countries quite explicitly. He told that the capacity building focus, oh, that is always quite important issue, particularly for developing economies, and absorptive, yes, capacities. That is a quite long-term issues, but that is a quite basis for accepting technologies. Local supplier participation and long-term commitments of governments and industry. I think these are quite the key factors in successful high-speed rail introductions, particularly for developing countries. Third, keynote speech 3 made by Professor Park. He talked very interesting presentations about the financing Korea's high-speed rail. many questions are raised by many participants. That means probably his presentation attracts a lot. First, he talked about the construction and operations. He said that the Korean high-speed rail is quite public-oriented. And at the beginning, 35% contribution from the public, but later on raised to 50% under some act. And also he talked about the quite unique systems of financing, transportation, facilities, special accounts. It's quite similar to US system, maybe, multimodal integrations. And out of total revenues, 40% are allocated to rail accounts. That is also quite interesting, maybe debating points. Vertical separation, I think that is quite popular in many countries, and also according to the poll, many people support that ideas. In the case of Korea's infrastructure is owned and operated by Korean National Railway, and the operation is done by the Korail. And Korean National Railway infrastructure owner repay the bond liability cost with the user's charge from Korail. And meanwhile, Korail pay the user charge to infrastructure owners. I think that is quite the typical structures. And he also pointed out infrastructure owner profitable but short of capital due to debt, while Korail suffer from chronic deficit. And interestingly, due to quite low fare, he shows the tables about the comparison, international comparison fares. Oh, I found that, yes, Korea's high-speed rail's fare is a bit cheaper. And also he talked about the PSO and also user fees. And he finally summarized the lesson for developing countries again. Earmarked account, that is quite debatable issues. Maybe Ministry of Finance may oppose against this kind of ideas, but I think that is one quite uniqueness. We also, Japan used to have, and vertical separation, public contribution, and also, interestingly, he talked a bit about the limitation PPP models. It may not be panacea, so he is a quite interesting topic. And plus, in the long run, rail plus property would be the one of the good financing schemes. Finally, keynote speech 4, yes, made by Professor Yeo, he also talked very interesting and also advanced topic, particularly using AI-based digitalizations for O&M. He first talked about the basic structures of AI-based O&M with the 6 layers: data, diagnosis, prediction, twin, simulation, and optimizations. And also he highlighted he didn't talk a bit today, but he, had some case issues, for example, real-time rail safety management systems or AI-based condition-based maintenance. And he highlighted the approach of a country or context-oriented framework, capacity or the readiness of a country's situations, market, and asset criticalities. These two are the quite important factors to decide what kind of maintenance strategy should be used. And options are several, but it could be summarized into the reactive maintenance. That would be quite traditional, and preventive or time-based maintenance, plus predictive or condition-based maintenance. And AI-based digitalization would realize the predictive ones. And the lessons for implementation, that's also quite important and also informative. Human in the loop approvals. Yes, always we doubt the AI, although AI may give us a very productive results. So how can human work in this loop of AI-based system? Model monitoring, cybersecurity by design. Yes, that is also another important concern for many business people, and open interoperability requirements. Okay, then based on these presentations, I try to summarize the lessons for Asian developing economies. Too many, so I just part show here. First, many presenters highlighted the importance significance of indigenous innovation. I think that it's a quite critical factor for successful high-speed rail introduction, particularly in a sustainable way. But to realize indigenous innovations, capacity is really important. So how can we develop capacities? And also long-term commitments and support from the governments and industries. I think these types of the stakeholder, the participations, these are the really important issues. That is the one important lessons for many countries. Second, government's financial commitments to high-speed rail. Vertical separation, yeah, as many people support that ideas, I guess that would be popular in many countries. Earmark account for high-speed rails, yes, and 40% is allocated to rail. But that would be a bit debatable probably. How was consensus made across mode? Particularly as far as understands, the revenue over transportation facilities special account, original source is gasoline tax or such a kind of road users probably is a tax. Then usually beneficiaries pays principle or beneficiaries principle. So the road revenue from road users should be used for the road investment. That is one of the principles. Then how can we justify the use of revenue from road users to public transit? That would be the one of quite important debates. Government's contributions, that is also another important aspect. Yes, already some questions were given. Originally 35% and later 50%. Yeah, that increase is quite important. I came to know that the 35% is simply because the IMF's some kind of yes situation. Yeah, but 50% finally. But what justifies share? Yeah, many people wonder that. Please note that in Japan, as far as I understand, roughly 2/3 of construction costs comes from the user charge through the JRs, and of course that origin is fare box revenues, right? And remaining 1/3 comes from the government's contribution. And in Korea's case, 50%. That is a quite interesting observation for me. And also, I am not sure from his presentation, are there any financial contribution from local governments? Only central government? That is a bit unclear for me. In Japan, both national and local governments should contribute to the construction cost. And the share of national government versus local government is 2-1. So I just to know what is the situation in Korea. Financial challenges in high-speed rail operations. Yes, high-speed rail fare is quite low according to presentation. I'd like to know how was it decided? Politically hard to raise fares in many countries, I know, and particularly in developing economies, maybe the fare is quite political issues. So I'd like to know the case in Korea. And the public service operation, PSO, yeah, that is also quite interesting for me. So if you have some ideas, please let me know. So what kind of legal support for this system? Sorry, this is the final. AI-based predictive maintenance, I think that is a quite promising technologies for reducing risk and cost, but still AI engineers are quite in short. So how can we develop capacities to manage AI, particularly if human should intervene into the systems? I think the high technology, high skills AI engineers are required. So how can we develop those capacities? And also, we are always concerned about the risk of cyber securities. So in the case of a high-speed rail, that is a quite symbolic infrastructure. So I think that would be the quite good target for terrorists, maybe. So we should care how can we discuss about cybersecurity risk. That's all. Sorry, a bit longer presentation than.
Thank you, Professor Kato. As always, your slides are very clearly summarized. And please keep that last slide for the remaining part. Yep. I'm going to invite Dr. Myung Sagong once again, President of KRRI, to comment on Professor Kato's presentations. Before I invite him, let me also thank once again all our all the four speakers, including Professor Dr. Sagong, and then Professor Park, Professor Lee, and Professor Yo. Thank you, Professor Kato, again. Dr. Sagong, please freely comment. This last 1 hour is going to be a free discussion, and we want to have a discussion with all the speakers. So you are the first one. Please go ahead.
Okay. I appreciate Professor Kato for the wonderful summaries and excellent open questions. So maybe you heard from Korean experience. We do not buy the technology. I mean, HSR technology is not just quickly buy. I mean, you cannot get by the procurement process. What we did is we set the plan and we try to observe the capacity and adapt and ultimately try to surface the foreign countries technology. So as Professor Yong-Sang Lee mentioned, there's a four trajectory like the transfer, capacity building, indigenous innovation, and we set the global market position. So I think the Professor Kato mentioned exactly on the first items, like the indigenous innovation. And I think that's the key for the success of the Korean HSR technology. And secondly, for the purpose part, he frankly very honestly mentioned about the HSR finance problem in Korea. I think this is not only the Korean problem. Profitable but capitally impaired. That's the kind of paradox. But any country who like to have HSR, they gonna face it. The key point is how you can surface that problem. To surface that problem, you need some wisdom that is not just by single one person. I mean, all collective wisdom and knowledge have to be shared, and there's a deep discussion have to be conducted. And also, I think the Korean TFSA model that maybe other countries have involved it, but that's the work to study. And lastly, the AI, the Professor Yaw mentioned, this is a right on time and exactly right moment for addressing this theme. And because in Korea, we are on the initial spot. I mean, KRI, we also starting to work on the AI and physical AI field. The point here is data, as Professor Yaw mentioned. I think the most important thing is the initial. The first step is you have to standardize the data format, and then you build the metadata and data management systems, and also you need some legal and governance frame to utilize the public data, especially in railway industry. The data sharing is very, very difficult. I think the other country has same problems, but
Yeah, we also have.
adapt. If you adapt the AI technology, I mean, data is very crucial. So we have to make the open discussion and how we can share the data and how we kind of protect some secret information. That kind of things have to be settled in advance. So today I don't know. I mean, the many audience can understand what the Korean speaker is trying to say today, but it is not just a Korean case. I mean, any other country who like to have HSR, they need very precise plans and execution powers, and also government backup is very crucial. Thank you.
Thank you. That's a very nice closing statement that you need a very clear execution plan and then government backup. And I also like the partnership with the academia. I was curious about the partnership with the industry, private industry. Dr. Sagong, how does that work in Korea? How the private industry is involved in R&D or also in other aspects of technology development?
Like, for example, HST, we work with the Hyundai Lotem. Maybe you heard of the company name. And once we initiate the national R&D, I mean, KRI, I mean, we are the government research, government funded research institute. So we lead the national R&D, and like Hyundai Rotem or other companies to join the R&D program. And once this thing has successfully, I mean, the results is successful, and then the government kind of issue the procurement through the Corel, and the Hyundai Rotem have a chance to manufacture the new trains and debit in the Korean rail network. So that's how it goes.
Okay. That takes me nicely to move on to the second part of the closing session. We're going to have a panel, and we would like to welcome several panelists. The first panelist is Professor Sutanto Sohedo from Indonesia. The second panelist is Professor Francesca Pagliara from Italy, and the third panelist will be Professor Nguyen Tung from Vietnam. So I was thinking we will dive into the panel discussion, Jiwon, if you're okay. So we will keep our speakers from the keynotes available with us. Let's have some interactive exchanges. So let me ask first Professor Sutanto a couple of questions. You know, we had these 4 sessions, so I thought maybe you might have comments on each of them, but specifically on the session 1 and session 2, that is the global partnership and financing. ADBI's Dean Bambang mentioned about Indonesia already constructing the first high-speed rail, and he mentioned that was not a planned decision, it was a political decision, and it was implemented. So I want to come from that angle, whereas the Korean one, the experience was, it was also a political decision, but they went through a systematic way of long-term preparation, transfer of knowledge. So I want your reflection now, as in your role in advising Indonesian government. What do you see as the role of and the lessons that you can pick from Korea, both for government as also for the university? Over to you, Stanto.
Well, thank you, Dr. Sitaram, and I would first appreciate, I think, the 4 presentation of the previous speakers, and also comments from Professor Kato, I think, are very good because they completed already, and I think it's quite comprehensive. Well, back to the high-speed rail in Indonesia, especially, you probably already know about the connection between Jakarta and Bandung. The focal points that we consider, that is 2 cities with the highest needs of traveling people. Yeah, it is not so far. It's just like 140 kilometers away. But then I think you are right that I think the decision to build this high-speed rail, what the so-called WUS, is actually more like a political decision rather than sound planning. That is why, to be very honest, to tell you here, I think it is very hard to make comparison probably with the other city or country like Korea, which is well developed and also well planned, I suppose, and they can make the imported technology becoming like players, I think, in the development of high-speed rail in industry. I think what we need to reshaping the condition of the high-speed rail. I think Indonesia is having the only high-speed rail in the Asian countries, the Asian, the Association of Southeast Asian countries. The first in the group of these countries, I think we have to show that this high-speed rail has to be a kind of successful story. It's a kind of success story that we have to share to other countries, not only to Asian countries. So this is very important, I think, to make a comparison that probably the developed countries like Korea, China, Japan, and European countries, probably they have the high-speed rail to share with us, for example, what would be the recovery or this kind of story, because one of the things that I would share probably is the ridership. This is far behind the expected number of ridership that we have in the high-speed rail. That is one thing. So in that way, you know that there will be some sort of impact to the revenue, of course, the revenue. And furthermore, then we will have some impact to the OPEX, the operation and maintenance costs for this. Needless to say, I think, what about the CapEx, the capital expenditure that we have to recover as well? I think this is a very crucial thing that the existence of the WUS or the high-speed rail we have in Jakarta-Bandung connection to sustain, in the future. I don't know whether some other countries may have some story to tell or some remedy to us to how to recover all these things. But I was thinking about the just now the one of the speakers was telling us about the financing, like the proportion of central and local government, like 35-65 and then 50-50. Well, to my thought, I think for Indonesia, the existence of the high-speed rail still has to be related to what the existence of the central government. So the best, I was thinking how to recover, probably I might be wrong as well, the possibilities. One of the ways, I think, how to attract the participation of people in financing. So we are thinking about probably the municipal bonds, for example, which is well, we don't know yet whether there are some big conglomerates probably wants to have some money to contribute or money to invest. But the thing is, I think we have to be able to tell the people that, well, high-speed rail is one of the priority in terms that this is a kind of making money. Because I believe businessmen, they don't want to invest money if they get their money back in very long years to come. So they have to be a quick wins that they can recover the money probably in quite a bit short time. That's why we have to be doing this in correlation with the cooperation of government and also the public. So one of the ways I think is the municipal bonds. But to that extent, probably, I don't know, I hope that among us, there are some economists to tell that this is going to be a kind of possibility that makes sense or probably it doesn't make sense at all. But the other things is I really want to know from all these speakers with all the experience, probably also from the other audience, do we look at this high-speed rail in terms of technology, but still, to me, high-speed rail is a public service. The things that we have to prioritize, why high-speed rail? Why not the others, mode of transport, for example? So we have to be able, I think, to think that there is a time value that probably being a kind of priority to many of the people. Most of the people may have to think that value of money. In terms of time, they can reduce to traveling, but I think some other thing is how to represent comfort. To travel quickly doesn't mean that you want to save your time alone, but probably want to have some comfort because you have some other purposes to do your travel. So I think this is a kind that we want to know exactly how to explore, from the experience of the modern countries that have the technology, of the high-speed rail, and how to they build the system and they invest the system and they get their money back from the operation of that systems. I think this is a crucial thing that probably Indonesia and probably also some other developing country have to learn from you all the modern or the developed countries in terms of developing the high-speed rail. Professor Sitaram, I think I would stop my question.
Thank you. That's a good one you brought. We have
Maybe
to
I can raise
value and
another.
evaluate not just savings of time, but also the value addition in terms of the quality of life. So that brings me to our Professor Pagliara. In fact, she Just returned from Thailand with a visit to the AIT. And Professor Pagliara, you wear many hats, and you are a vice chair for the UIC, Alliance of Universities for High-Speed Rail, and you also conduct an annual conference, very highly popular, on the socioeconomic impact of high-speed rail. So I thought I will give you the floor, and also you are an advisor for the European Parliament. You made a briefing on high-speed rail, so you are kind of a protagonist who promotes high-speed rail. So from your reflections, Europe has mixed experience. How does the Korean experience offer new pathways or insights? Maybe you might want to share your reflections, and this would be useful for Asian countries. Over to you, Professor Pagliara.
Dr. Sitaram, first of all, many thanks for inviting me, and I feel really privileged to be part of this webinar on this very interesting case study. Well, definitely Korea's high-speed rail experience is increasingly seen in Europe as an example of how a country can move from being a technology importer to becoming a global innovator. This is very clear from this webinar through long-term industrial policy, institutional learning, and sustained investment. Well, I was invited several times to the European Parliament by a former member of the European Parliament from the Netherlands. And I can say that from my briefings, three main lessons have emerged. First of all, technology absorption is a long-term process. And Korea initially relied on foreign expertise, such as the France TGV program, but however, it did not simply import the technology. It simultaneously invested in domestic engineering, research institutions, supplier development, and workforce training. And this is exceptional, according to me. Over time, this allowed Korean companies to develop their own rolling stock, signaling system, and maintenance capabilities. The key lessons is that technology transfer creates lasting benefits only when it is combined with domestic innovation capacity. The second lesson is that institutions are as important as technology, and this is also clear. Korea's success depended on close coordination between government, infrastructure operators, manufacturers, universities, and research institutes. Stable investment, effective project management, and continuous performance improvement help Korea achieve high standards of safety and reliability while keeping operating costs competitive. In other words, I think that infrastructure investment can create long-term economic value only when it is supported by strong institutions. Third lesson, high-speed rail should be seen as more than a transport system. It can also support industrial competitiveness, regional development, digitalization, and decarbonization. This is particularly relevant for Europe, where rail investment is closely connected to the Green Deal and broader industrial policy. And Korea demonstrates that high-speed rail can improve mobility while also supporting economic development and the creation of export-oriented industries. For middle-income countries, I can say that Korea offers several practical lessons. Technology transfer should include training, joint research, supplier development, and technology localization. And at the same time, strong regulators, competent operators, and reliable maintenance capabilities should be developed alongside the infrastructure. Finally, I think that Korea experience shows that indigenous technological capability cannot be created overnight. It requires successive stages of learning, adaptation, and innovation supported by consistent policies and decades of investment. The greatest value of high-speed rail is not simply moving passengers faster. It is also the opportunity to build technological and industrial capabilities. And I think that Korea shows that with strong institutions and sustained investment, technology absorption can eventually become indigenous innovation and in international competitiveness.
Thank you. Yes, yeah, if you want to add some more, please.
Yes, of course, I can definitely add the economic part, the economic benefit, the socioeconomic benefits, which is my main field of research, as you know. You know that traditional financing models for high-speed rail usually focus on capital costs, operating revenues, debt, and ticket revenues. These are important, but there is the other side of the coin. That means that most significant benefits are broader economic impacts that are often underestimated in conventional financial assessments. So the first one is land value appreciation. High-speed rail can increase property prices around the high-speed rail station and along, development corridors. So better accessibility attracts business, housing, investment, generating high local tax revenues. Part of this increase in land value can potentially be captured through mechanisms such as better levies, joint development, or tax increment financing, helping to finance the infrastructure itself. The second benefit is the regional development and equity. High-speed rail can connect the secondary cities with the major economic centers, improving access to jobs, education, healthcare, and investment. And these benefits may not appear directly on the railway balance sheet, but they can increase productivity, reduce regional inequalities, and support more inclusive economic growth. Tourism is another important benefit. Faster and more reliable connections can increase visitor numbers and encourage longer stays. This stimulates spending in hotels, restaurants, retail, and cultural activities, creating employment, new jobs, and additional tax revenues well beyond the railway operator. There are also significant environmental and productivity benefits. We were talking about, the environmental impacts before. There is a shift from, parallel runways and parallel highways to the tracks. So high-speed rail can reduce emissions, congestion, and accident costs. At the same time, shorter travel time improve labor mobility and business connections, effectively expanding labor markets and increasing economic productivity. The main implication is that high-speed rail investments should be evaluated through the whole economy cost-benefit framework rather than through narrow financial indicators alone. Decision makers should consider not only fair revenues, but also land value increases, regional development, tourism, environmental benefits, productivity gains, and social inclusion, which is an important aspect. So high-speed rail should not be judged only by whether ticket revenues can cover the construction costs. Its real value lies in the wider economic and social benefits it can generate over several decades.
Very nice. Let me interrupt you there because Professor Yoshino had extensively done research on this. Let me now welcome Professor Nguyen from your reflection, because Vietnam is a rising star in the economic trajectory, and you have declared already to build a high-speed rail quite some time ago, and you are going to look forward to work with countries like Korea. So maybe the reflections from you, what will you look in terms of global partnerships, now that you have heard the story of South Korea vividly explained by our four experts, what do you think a country like Vietnam should look for, both the knowledge transfer, the partnerships, and more importantly, the way they structure the contract? I think that one-liner was very good, that knowledge transfer is not just easy, it should be part of the contract. I think that was a very loud message. Over to you, Professor Nguyen.
Yeah, thank you, Dr. Setha Ram. I'm very happy to join this webinar because I learned a lot from the Korean case. So we in Vietnam now are going to speed up the process of constructing the high-speed railway projects. And from my side, I think that we have many lessons learned. Of course, it has been partly pointed out by Professor Kato, but I still want to talk something that we think that is valuable for the Vietnam case. So the first, in the practitioner perspective, I think that yes, we have to looking for like a life cycle cost. I mean, not only on capex but also opex. So this means that we have to carefully select the technical the technology related to high-speed railway. So it's very important for us to looking for an appropriate technology because it's related to the long-term operation and maintenance. And also, it's also one of the indicator for the donor to fund our projects because we are still have a very limited budget. So I do think that we have still have to looking for ODA support from ODA. So life cycle cost is very key indicator for that. And also we by looking for the long-term benefits, we can we have to think about the establish standard, I mean, the technical standard for us to mitigate the risk to highly dependent on a single supplier. So it's very critical for us. And also, we also learned from the case of Korea about the digitalizations. We learned that it's very time consuming and should be invested in phases. So I think these are very important for us to in the coming times. Regarding the financing issues, I think that the vertical separation is very good example for us to learn. But also we now realize a very important lesson about the profile by separating, for example, the Korean case, they have Korean National Railway and they also the Korea. But by separating like this, it make the financial status of the two entity not so sustainable in the viewpoint of the donors or the ODA lenders. So it's also the case. But I also learned from the way that the Korean people did for their case. The establishment of the Korea Transportation Facility Special Account, I think it's very a good move by providing a secure, providing a warranties for the sustainable of the projects. And so that's also another interesting point that we're looking for the cost sharing ratio. Of course, as already pointed out by Professor Kato, that the share between the central government and the local government is also very essential. And we really want to learn more about how the Korea case, the Korea people, they can define the 50-50 ratio to support the projects. And finally, I think that we have to think about some, not only the constructing the high-speed railway project, but also another project, I mean, the training and educating project, which is, I think, should be go in advance compared to the construction work. I mean that the capability of the research of the engineers and of the collaboration between the government, the academic institutions, and the company is very essential for the development in the coming phase. So I finished my comments.
Very nice. Thank you very much. So one of the important messages that I know Professor Park made quite provocative comments in the financing aspect, but I think Professor Dr. Sagong nicely summarized it. It's wisdom. You know, the cost recovery is a wisdom, and idea is to make that available. I think Korean government has kind of pursued a very good policy, which brings us now really a point to discuss. Let me invite our colleagues from India who are now building the high-speed rail. One of the messages I learned from Korean experience is that you did take 15 years until the train, after the political commitment and the train was running, and then you spent more than 8 years to build your own capacity. So this looks like empirical information to me. Many countries take quite some time, but they do succeed very well. So, Mr. Akshay Rathore, are you able to speak?
Yeah, thanks, Dr.
Share your
Siddharth.
reflections and ask any questions, please.
Yes, thank you. Actually, I am involved in the Indian high-speed rail construction, which is being funded by the ODA. So Professor Nguyen also explained that in Vietnam, they are also maybe going in that direction. So in Korea, it was very remarkable to see that within 26 years, they have transformed themselves from technology importer to exporter. So that is something we also are aspiring and are having tie-ups with academia and trying to build indigenously some solutions which will result in maybe cost optimization for our maintenance for our current corridor, and also will help in indigenization of technology for future HSR corridors. So that is also one of the challenge, because since the technology which we are importing, they are also having their own sets of IPR. So, and they have the right to protect their technology because they have put in so much efforts and years to build it. So that is also one of the challenges, that when you are transforming your understanding from know-how towards know-why, which was very interesting in the previous seminar. So then you have to go into the design and the nitty-gritties and the little things, so that you can transform that technology towards your country's conditions, such as the climatic conditions and what will work best in your local environment. So that is something which we are aspiring to be, at least ultimately in the few years, we should reach in that direction. So this question was actually answered by the Korean professors, that we have to, in a way, negotiate our know-why approach, so that you have to separate it from the IPR and the contract part, and simultaneously develop your indigenous capabilities. You have to like go into the R&D from the day one itself. So that is something very interesting and very inspiring to say. Thank you for this seminar, Sitaram.
Very, very happy. Thank you for the nice comments. So you do have the High Speed Rail Innovation Center in NHSRCL, which your first MD set up. So you may continue to do such research, and we'll be very happy to support such efforts. Let me invite another colleague, also from India's NHSRCL, Rajiv Mishra. You can also make your reflections and also ask any questions, please.
Yeah, thank you so much for giving me this opportunity. And I would like to say that it was a very informative and excellent presentation. My question is basically on some kind of a tactical issue, not the strategic issue. Should I say that we have been hearing about the collaborative effort of the three major pillars, that is the government and the manufacturers, and third one is the academia. Now, from a know why perspective, yes, it is the synergy required by these three actors is very, very important. We understand that. Now, how to actually do it? How to actually put a commercial kind of a platform for this arrangement? Because from a practical perspective, when we start such kind of a project, so government normally either select some, I am talking in terms of rolling stock, let's say. So government engages some rolling stock manufacturer. They have got a repository of their experiences, their models, their makes, and all kind of designs. But to really absorb technology from outside, we require academia also to be involved in this, so as to have a continuous digestion and innovation capability made. Now, how do you build up this chain or this web or this ecosystem? So I would like to hear more practical uh, experiences from the learned panel about how they have gone through this particular thing on ground in Korea, while, let's say, indigenizing any part, any portion, maybe the track portion, maybe the rolling stock portion, or a part of rolling stock portion. How they have knitted well all these three stakeholders. Thank you.
Okay, for this one, if it's okay, I think the scribe of the 20-year history is Professor Yongsang Lee. Is that right? So maybe would you like to share some, and then we can invite Dr. Sagong or Dr. Park and Professor Yo to add up. Please do respond to the comprehensive queries from both Indian colleagues. How do you actually do it? Yeah, philosophy is one thing, but what did you actually do and how did you do it? Could you summarize briefly for us? Go ahead, Professor Lee.
Oh, yes, sir. Thank you for your fruitful comment and lesson. So, especially thank for your Francisca Parilia.
Pagliara, sì.
Yes, thank you for your good comment and good suggestion. Actually, I'm responsible for the 20 years high-speed railway history in Korea. So, and there are so many things in Korea during 20 years. So that's why maybe it's something too difficult to shortly, but however, R&D is so important. We are simply at the same time we are constructing and importing and doing R&D all together. It's so important. That's why we make the good circulation. Something happen, is it possible? But we have to, during the R&D, we are checking the problem and feedback. It's one of so important. It's our successful story. And you mentioned about the profit. Profit is so important. Ridership is so important. At the same, in the beginning, we don't have any passenger. It's something below the ridership, but the high-speed railway and high-speed rail system is so convenient and profit not only passenger but also government economic system. That's why the government agreed the impact of the high-speed railway. Sometimes it's something the important things. So the France has using the high-speed rail connecting the conventional line. It's one of the good point. So just only the high-speed railway cannot gain the money. It's something difficult. There are so need huge capital. That's why network is so important. In Korea, we make the profit line, Gyeongbu line is profit line. It's so profitable. But the Honam line, the other line is not profitable. At that time, we have an idea to connecting to the two lines, Gyeongbu line, profit line, and the conventional line. It's one of our good strategy. We learn, actually, at that time, I've been their friends. I learned from France and Germany. They're using the conventional line in the beginning towards the get the profit is one of the things. And our team today, we are discussing about the cerebral perspective. Maybe you can understand all of them. So, but we have some knowledge about to succeed this project. That's why, so I would like to suggest you the KLRI is the Sa공명 president are joining is the key person. And so would you contact and communicate afterwards? So it's the starting point to communicate Korean high-speed railway. I think the Korean rail system is one of the good lessons towards the developing countries. And so at the time, at the beginning, the 1989, at the time, the economic level is the worldwide 50. We cannot imagine to making a high-speed railway. Even though at the time, just only 5 countries have the high-speed rail. Japan, something like that. But at the time, the visionary leaders make the clear the goal. After 2 years, we will be an advanced country. That's why we need 2 things infrastructure plan. One is hub airport and one is high-speed railway. It's one of the good suggestions for us. That's why at the beginning we were so difficult there are so controversy about to make high-speed rail. It's the huge investment. That's why but however, so at the time we make the government the supported the R&D program. So at the time simultaneously there's something trial and error because it's something simultaneously making and importing the technology, making the construction, but I think R&D is something simultaneously doing that one. That's why it's just one of the good circle. So it's one of my suggestion. And the other one is the Pagil mentioned about it. This project is not transportation policy. That is that is infrastructure and investment and economy policy. That's why I think so. Some of the if the developing countries suggest we would like to make the high-speed railway, maybe BC ratio is not enough. That's why the economic side deny it and they are complaining. But we have to persuade about this project is not only transportation policy but also economic and the regional and the good policy and industrial policy. That's the high-speed railway is one of the definition. What is the definition of high-speed rail? Each country is so important. Just only is a convenient, it's a something ridership, something like that. It's not only that one, but also that we have to make the social impact and economic impact. So and R&D and making and then the important one is making a governance institution. Not only R&D. Kerala is an important role to make a Korean high-speed railway. So and manufacture Rotem and some other countries. That's why we have to make the long-term the project vision and the coordination. Sometimes if we not efficient to make the money and we use the PPP plan. So long-term vision is so important for us. So it's something long story. That's why I think would you contact our team, especially Kerala represent Sagongmyeong is the best, and the institution is the strong building. That's why human resources is so good. That's why from now on, so I am happy to understand your saying and Korea the situation. So from now on, we would like to communicate and discuss about more deeply.
Thank you. Thank you so much. That's very comprehensive. Jiwon kindly shared the 20-year history report in the chat, so please later download. We have last 10 minutes. I'm going to invite 2 colleagues, Professor Yoshino first to share his reflections, and today he kindly joined. He's our pioneer in showing a new way to evaluate the wider economic impacts of high-speed rail, and he has done extensive research, and I had the privilege to work with him. Professor Yoshino, what are your reflections and takeaway for today, and any suggestions for Korea as well?
Okay, thank you very much. So very active and very discussions. I have 2 comments about the share of 50-50 or 3565. I think if we can use the translog production function, we can look at the spillover impacts of high-speed rail. Then, as Professor Framitari said, there are many different tax revenues will rise. Not only property tax revenues, but if employment will be increased, then income tax will rise. A new company may come, then corporate tax revenue will rise. Then we can look at all those various kinds of tax revenues, how much percent it will be collected by local government, and how much percent will be collected by the central government. Then that should be the share between the burden of central and local government. And also that it was pointed out, land price capture is not the only one. There are many different impacts into the economy, and I often measure those looking at spillover tax revenues created by various infrastructures. So I think today's discussion was very constructive, and also Korean experience will have a big lesson to developing countries who are going to construct a new express highway, high-speed rail. So I've learned a lot, and thank you very much for all the contributions and great discussion. Thank you.
Thank you, Professor Yoshino. So just for our members who have joined here, we have Ayushman Bhatt, who is coordinator together with Professor Kato. I'm also a member of that, and some other colleagues are also members of that. We have an international research group who have been keenly studying high-speed rail in many countries. And if data is available, we are quite happy to do comparative research, and that's the motivation for that. So I'm going to request Ayushman to make some comments. Before that, before I invite Ayushman, he'll be the last speaker. We have a colleague who has been joining from the Philippines, Paul Pascual, and writing several interesting comments throughout all the sessions. So I would like to give you the floor for making a brief comment or observation or overall takeaway for today's webinar. Paul, over to you.
Hi, thank you everyone. Thank you for your sharing your thoughts and also your wisdom. And also we learned a lot from the experience of developed countries, especially the South Korea. The experience of South Korea, Vietnam, Indonesia, Japan, and Italy, and the European Union provides an important lesson for us in the Philippines because me as a businessman also an entrepreneur in our country, we are looking forward for this modernization because high-speed rail creates economic activity and also improves different lives and different cities all over our country. And also, successful railway modernization is not simply a matter of purchasing trains, building tracks, or importing advanced technology. It is a long-term process of building institutions, technical capability, financing systems, human resources, standards, and public trust. These are the thoughts that are I can take it away from us and how we can do it better. And also, we learned a lot from your experience. And also from South Korea, the Philippines can learn the importance of turning technology transfer into national capability because we have before the Philippines, as I remember when I was in high school or in my teenage years, Philippines both rotem trains, and still it is also remembered in our times now. And also some of the trains that we use came from Japan and also from the Czech Republic in Europe. That's why we are admiring to have a better train systems in our country. And I realized many things on this discussion. And Korea initially relied on foreign technology first, but gradually developed its own expertise in railway engineering, rolling stock signaling, research, operations, artificial intelligence, and maintenance. The lessons for the Philippines is that foreign partners should not only construct our railway systems for us, they should also help Filipino engineers, universities, researchers Researchers, technicians, government institutions acquired the knowledge needed to operate, maintain, improve, and individually innovate these systems to ourselves. The current ADB assessment of Korea experience explicitly identifies this transition from imported technology toward domestic capability as one of its most important lessons. And very thankful for these discussions for our experts from the Republic of Korea. And also, Korea also teaches us the digitalization and AI should be built on strong foundations before expecting artificial intelligence to predict failures or automate maintenance. The Philippines need reliable asset record sensors, common data standards, cybersecurity, skilled personnel, and clear accountability. AI should be there for augment the judgment of railway engineers rather than immediate replace human expertise. This approach is particularly important for safety critical infrastructure. Vietnam also offers a refreshing valuable lesson because we are neighbors, and also Indonesia. And for the Philippines
Thank
also,
you.
we are very thankful for this. And thank you very much for the opportunity that you have
Thank
shared
you.
to
Thank you,
us.
Paul.
Thank you.
Let me now request Ayushman. You have 2 minutes before we close on clock. Ayushman, go ahead.
Okay, I hope I am audible. Thank you, Dr. Sitaram, for giving me the opportunity to make brief comments. I must thank all the speakers and all the panelists. In the interest of time, I would not be speaking too long because I want to maintain the ADBI's tradition of finishing webinars on time. But one point which I may add upon to the discussion is when we talk about domestic technology development for high-speed rail, we also need to think about the management of the intellectual property, because from the donor side, they may want to protect their decades or even generations of efforts which have gone into the technology of them. But at the same time, on the receiver side, they want to learn as much as possible from the limited framework or financial challenges which are already touched upon. So how do we really manage the intellectual property? That is something which is uh, not very developed in developing parts of Asia, or the ecosystem in general is not existing well. So I would like to learn more about this from the Korean case, and I agree with the panelists and speakers that the Korean case serves as a very good role model for initially importing a technology and then gradually translating into indigenous frameworks and ecosystem. We are keen to learn more as IRG of Eastern Asia Society of Transport Studies for the case of Korea, as well as other cases. So please keep in touch. Thanks again for the opportunity.
Thank you. With that, please join me to, first of all, thank and congratulate both Jiwon Lee. She's our intern from Seoul National University. She's done a tremendous job in putting this together, researching and preparing. And Nia, our webinar chair for all the series, and she has really coordinated very well. And we had two-part series this time. And thank you all. And I now hand it back to Jiwon to close the session.
Thank you, Dr. Sitaram, for your thoughtful closing reflections and remarks. And we would like to announce that we will also post this webinar on our social media account and ADBI website. You can find the recording and presenter slides on the event website. Also, this is a reminder of requesting your participation of the survey. We would appreciate it if you could take a brief moment to complete the survey provided through the link in the chat post-webinar. Your valuable insights and feedback help us continue to improve the quality and relevance of our future webinars. On behalf of ADBI, we extend our sincere gratitude to all speakers and participants for making today's discussion rich and engaging. We hope the insights shared in today's webinar will spark further dialogue and encourage actions toward advancing high-speed rail networks in Asia and beyond. Let this be the beginning of continued collaboration and knowledge exchange across our shared communities. Thank you, and we look forward to seeing you at our future events. Have a wonderful day. Goodbye.
Thank you very much.
Thank
Thank
you.
you all. Thank you.
Goodbye, everybody.
Thank you.
See you
Thank you.
again.
Bye.
See you, Dr.
Bye.
Scott.
Congratulations. Thank you very
Fabula.
much. Thank you.
Yeah.
Thank you, everyone.
Thank you.